It is Wednesday, January 28th, 2026. And right now we are watching a weather map that looks completely broken.
It really does.
If you are in Florida or if you have family down there, you are already feeling the leading edge of this. But if you're just tuning in, you need to understand that this isn't just a chilly couple of days. We are witnessing an atmospheric setup that is, it's historically significant. We are talking about a cold snap shaping up to be one of the most severe events the Sunshine State has seen in roughly 15 years. We're looking at comparisons to the massive Arctic outbreak of December 2010.
It is a statistical anomaly, to put it mildly. Usually when we look at Florida winters, we see variability, a day of cool air, then a rapid return to the 70s. This is different.
It feels different.
We are watching a massive coherent Arctic air mass just spilling south, bringing potential record-breaking lows, long-duration freezing temperatures, and wind chills that are, frankly, dangerous for a population that isn't built for them.
It's the kind of weather where you walk outside and your brain takes a second to register that you're actually in the subtropics. But before we break down the physics of why this is happening and why people are whispering about snow in Tampa, we need to introduce ourselves properly. Welcome to Meteorology Matters, the podcast that dives deep into the science, chaos, and stories behind the weather that shapes our world. This show is created by meteorologist Rob Jones. Now let's get into today's episode of Meteorology Matters. So usually when we sit down to talk about Florida weather, the bingo card is pretty standard. We're talking about, convective thunderstorms, maybe a tropical cyclone. Humidity levels that make you feel like you're swimming in the air, or heat indices. But today the vocabulary has shifted entirely. We're seeing terms like deepening low pressure, Arctic intrusion, and advection.
And Gulf effect, which is a personal favorite of mine.
We are definitely going to get to the Gulf effect because that is the headline grabber. But I want to start with the architecture of this event. What is actually happening in the atmosphere to open the freezer door like this? Because this feels more aggressive than a standard cold front.
It is much more aggressive. To understand this, we have to look at the pressure systems involved. Right now, we have a weak area of low pressure that's sort of drifting across the Gulf of Mexico.
Okay.
Now, on its own, a weak low in the Gulf isn't headline news, but meteorology is all about context and timing. This low is moving toward the Atlantic.
And once it hits the Atlantic, it hits the turbo button.
Essentially, yes. Late Friday into early Saturday, as that system moves over the open Atlantic waters, it's going to deepen rapidly. When we say deepen in meteorology, we mean the central pressure is going to drop like a rock.
Let's pause on that for a second, because I think pressure is one of those terms we hear constantly but maybe don't fully visualize. When the pressure drops, that means the storm is getting stronger, right?
Correct. Imagine the atmosphere is trying to balance itself. You have high pressure areas and low pressure areas.
Yeah.
Air always flows from high to low, trying to fill the void.
Okay.
The lower the pressure in the storm, the stronger that vacuum effect. It creates a steeper gradient.
So it's like a drain.
A massive atmospheric drain. And because this low is intensifying so rapidly off the East Coast, it acts like a giant pump. The circulation around a low-pressure system in the northern hemisphere is counterclockwise.
Right.
So on the backside of this storm, the western side, is just ripping air down from the north.
And it's not pulling that nice, balmy Caribbean air we usually enjoy.
Not at all. Because of the trajectory, it is tapping into a source region way up in the Canadian interior. It is pulling a dry Arctic continental air mass straight down the Florida peninsula.
It's a direct shot.
It's a direct corridor. There are no mountains to block it, and because the low is deepening so intensely, the speed of that transport is high.
That explains the intensity. But the thing that feels different about this forecast is the duration. Usually, a cold front in Florida is a cameo appearance. It shows up, you wear a jacket for one night, maybe you cover the basil.
And then it's gone.
And then by noon the next day, you're sweating again.
Exactly. That's the typical pattern. The high pressure builds in, the wind shifts off the ocean, and you warm up. This is different. This is a long duration event.
Multiple nights.
We are looking at repeated cold mornings. We aren't just talking about Saturday night. We are talking about Saturday, Sunday, Monday. Deep freezes. And the driver of this duration is something called cold air advection.
Advection. That is a great word. It sounds like something from a physics textbook.
It is. In thermodynamics and fluid dynamics, advection is the transport of a substance or quantity by bulk motion. In weather, cold air advection just means the wind is physically transporting cold air molecules into a region. It's not just that the sun went down and the ground cooled off. It's that the wind is essentially a conveyor belt. continuously dumping freezing air from the north into the state.
So even if the sun is out, if that conveyor belt is running, it's fighting against the warming.
Precisely. And that is why the daytime highs are going to struggle so much. You have the sun trying to heat the ground, but you have this relentless north-northwest wind just replacing any warmed air with new cold air.
Now, let's pivot to the thing that has the internet losing its mind. The S word.
Yes.
Snow
Yeah.
in Florida, specifically around the Tampa Bay area. I feel like every time the temperature drops below 40, someone starts a rumor about snow. But this time, it's actually in the forecast discussion from the National Weather Service.
It is. But we have to be incredibly careful with how we frame this. We need to avoid the hype train.
Absolutely.
We are discussing a legitimate scientific possibility for coastal areas like Pinellas, Pasco, Hernando, and Citrus counties. But the mechanism is not a blizzard. It's not a winter storm system like you'd see in Boston. This is Gulf effect snow.
Okay, Gulf effect. I assume this is the cousin of lake effect snow.
It is the exact same physics, just applied to a different body of water.
Break that down for us. How does lake effect, or in this case, Gulf effect, work?
It's all about the temperature difference, the delta T as we call it. You have this incredibly cold, dry Arctic air mass that we just described.
Right, the stuff coming down from Canada.
Yeah, it moves out over the Gulf of Mexico.
Mm.
Now, the Gulf of Mexico is a massive reservoir of heat. Even in January, the water temperature is significantly warmer than the freezing air moving over it.
So you have a warm bath on the bottom and a freezer on top.
Exactly. And the atmosphere hates that kind of imbalance. It wants to reach equilibrium. So the warm water heats the very bottom layer of that cold air. Warm air is less dense, so it wants to rise.
Of course.
It picks up moisture from the Gulf and shoots upward rapidly into the freezing layer above it.
It's like steam rising off a hot cup of coffee on a cold porch.
A perfect analogy. As that warm, moist air rises, it hits the cold air and condenses into clouds. If the air is cold enough through the entire column, that precipitation forms as snow crystals. This creates these narrow, energetic bands of clouds that stream off the water.
So the Gulf of Mexico, the thing that usually keeps Florida warm and humid, is actually the engine creating the snow in this scenario because the air above it is so shockingly cold.
Correct. But here is the catch, and it's a big one. For this to impact land, the wind direction has to be perfect. If the wind is purely from the north, those snow bands stay out over the open water. If the wind has a bit of a westerly component, you can push those bands on shore into places like Pinellas or Pasco counties.
It's a game of angles.
It is geometry and thermodynamics combined. The National Weather Service is looking at a very narrow window of opportunity here. We are talking about late Saturday night, around 11 p.m. through roughly 7 a.m. Sunday morning.
So if you sleep in on Sunday, you miss it.
Likely, yes. And we have to manage expectations here. We are not talking about accumulation. We are not talking about building snowmen in St. Pete.
Why not? I mean, if it's snowing, why wouldn't it stick?
The ground is simply too warm. Florida soil holds heat. The pavement, the rooftops, the grass, they're all well above freezing. As soon as a flake hits the ground, it will just melt.
So it's a look up, not down kind of event.
Exactly. The confidence in this forecast is low, around a 20% chance. But the fact that it is non-zero is meteorologically fascinating.
There is another term that keeps popping up in the technical discussions regarding this snow chance. Wet bulb temperature. I feel like this is one of those concepts that separates the casual weather watcher from the deep diver.
Yeah.
Why does the wet bulb matter here?
The wet bulb temperature it's critical in marginal snow events like this.
Hmm?
It helps explain how snow can fall, even if your thermometer says it is 36 or 37 degrees Fahrenheit.
Which feels like magic. Water freezes at 32. If the air is 37, it should be rain.
You would think so. But the key is that this Arctic air mass is incredibly dry. It has very low humidity.
Okay.
When air is dry, evaporation happens very efficiently. And evaporation is a cooling process. It takes energy heat from the environment to turn liquid water into gas.
Right, that's why we sweat. The evaporation cools our skin.
Exactly. Now, apply that to a snowflake falling from a cloud. It falls into a layer of air that is, say, 37 degrees. But because the air is so dry, water molecules on the surface of the snowflake evaporate instantly. That evaporation cools the air immediately surrounding the snowflake.
So the snowflake is creating its own personal air conditioning unit as it falls.
That's a brilliant way to put it. It creates a microenvelope of freezing air that insulates it. This allows the snowflake to survive the trip to the ground without melting, even if the ambient temperature is technically above freezing.
Wow.
That's why we look at the wetback. It accounts for that evaporative cooling potential.
That is fascinating. So the dryness of the air is just as much of a weapon here as the temperature itself.
It is. But again, I cannot stress this enough. Do not expect a winter wonderland. The headlines might scream, "Snow in Florida," but the reality is likely a few flurries that melt on impact. The danger in this event isn't the snow. The danger is the cold.
And that is the perfect pivot point. Because while the snow is a novelty, the temperature drop is a hazard. Let's look at the statewide impacts. Florida is a massive state. North Florida is somewhat used to this. Tallahassee sees freezing temps most winters.
They're a bit more prepared.
A bit. But this cold air is pushing way south.
It is penetrating deep into the peninsula. We are seeing hard freeze warnings expected for North and Central Florida. But when you look at the guidance for South Florida, that's where the rarity of this event becomes clear.
How far south?
We are seeing forecasts for low temperatures dropping into the 30s as far south as Miami-Dade County.
Miami in the 30s. That is not something the infrastructure there is designed for.
Not at all. We have freeze warnings popping up for Glades and Henry counties. These are major agricultural areas.
Yeah.
But for the millions of people living in the metro areas, the real story is going to be the wind chill.
Wind chill. It's the number everyone quotes, but I think people sometimes dismiss it as just how it feels. But it's a physical reality, isn't it?
It is absolutely a physical quantity. It measures the rate of heat loss from exposed skin. Your body is a heat engine. It is constantly generating thermal energy.
Right.
On a calm day, your body heats up a very thin layer of air right next to your skin. That layer acts like an invisible insulating blanket.
It keeps the cold at bay.
Right. But when the wind blows, it strips that warm layer away. That is convection. The wind physically carries that heat away faster than your body can replace it.
And that's the danger.
The stronger the wind, the faster the heat loss.
No.
So when we say the wind chill is in the 20s, we are saying that your body is losing heat at the same rate it would if it were a calm day at 20 degrees.
And we are expecting wind chills in the 20s in South Florida.
Yes. Combined with that brisk north wind we talked about earlier, and for a population that doesn't own heavy coats, and for buildings that often have single-pane windows or, those jalousie windows that don't seal well, that rate of heat loss is dangerous.
And we have to talk about the duration again. This isn't just Saturday night. I've been reading that Sunday night into Monday morning might actually be the coldest point in terms of raw temperature. Why is that?
It comes down to the wind dying down and the air drying out even further. By Sunday night, that low-pressure system has moved further away. The pressure gradient relaxes, so the winds calm down.
Okay, so less wind chill.
Right, but the air itself gets colder. Because the air is coming from the continent, it is bone dry.
No humidity blanket.
Exactly. Water vapor is a greenhouse gas. It traps heat radiated from the ground. When you remove the humidity, the heat that the ground absorbed during the day just radiates straight out into space as soon as the sun goes down. It's called radiational cooling.
So you need three things for that.
Clear skies, calm winds, and dry air. Put them together and the bottom falls out of the thermometer.
So Sunday night is when we might see those record lows.
That is the window for the absolute lowest mercury readings, yes.
I think it's important to contextualize this too. Florida isn't the only place suffering. This is part of a massive national system.
It is. This is a continental scale event. The jet stream, that river of high-speed air in the upper atmosphere, has taken a massive dip south. It's called a trough.
It's like a big U-shape.
A huge U-shape that has dug out a massive portion of the central and eastern United States. We are seeing temperatures 30 degrees below average across a huge swath of the country.
I saw some numbers on the travel chaos. Over 17,000 commercial flights canceled recently.
It's a cascading failure. When you have major hubs in the Midwest and Northeast impacted by winter storms and de-icing delays, it ripples through the whole network. Planes aren't where they need to be. Cruise timeout. It's a mess.
And historically, we are comparing this to 2010. I remember that winter. It was relentless.
It was. The December 2010 event is the benchmark for modern Florida cold snaps. That was the year we had widespread agricultural damage, massive fish kills because the water got too cold.
And the iguanas falling out of trees.
And the iguanas.
Yeah.
And significant strain on the power grid. This 2026 event is tracking very similarly in terms of the depth of the cold air and the duration.
So we've established the what and the why. We have the deepening low, the advection conveyor belt, the Gulf effect mechanics, and the radiational cooling. But this show is Meteorology Matters. It matters because it affects us. We need to shift gears to the how. How do we get through this?
We need a survival guide. And in the emergency management world, we stick to the 4 Ps.
Mhm.
It's a simple mnemonic device, but it covers the critical bases: people, pets, pipes, and plants.
Let's take these one by one, starting with the most important, people.
It seems obvious, but hypothermia is a real risk, even in Florida. Maybe especially in Florida because people underestimate it.
Okay.
We need to distinguish between frostbite and hypothermia. They're not the same thing.
Break those down. What are the symptoms?
Frostbite is a localized injury. It's when the tissue itself freezes. It happens to the extremities. First, fingers, toes, earlobes, the tip of the nose. Your body restricts blood flow to these areas to keep the core warm.
So what should we look for?
The skin turns pale, white, or waxy, and crucially, you might lose feeling. If your fingers go numb, that is a big warning sign.
What do you do?
If you suspect frostbite, warm the area slowly. Do not use hot water. The sudden temperature change can damage the tissue further. Use warm water or just body heat.
Okay. And hypothermia.
Hypothermia is systemic. It's when your core body temperature drops below 95 degrees. This is life-threatening. The scary part about hypothermia is that it affects the brain. You get confused.
You called it the umbles earlier when we were chatting.
Yes, the umbles, stumbles, mumbles, fumbles, and grumbles. If someone is shivering uncontrollably, slurring their speech, stumbling around, or seems unreasonably irritable or confused, they need immediate help. They might not even realize they are cold.
And with the clothing layers, right? That's the go-to advice.
Layers are key. You want to trap air. But let's be specific. Wool is better than cotton. Cotton loses its insulating value when it gets wet or damp. Wool retains heat. And here's a fun fact. Mittens are warmer than gloves.
I never knew that until you mentioned it. Why is that?
It's about surface area and shared heat. In a glove, each finger is isolated and surrounded by cold air. In a mitten, your fingers are all touching each other, sharing their radiant heat in a single air pocket. It's just much more efficient.
Now, we have to talk about the silent killer, carbon monoxide. Every time we have a hurricane or freeze, we see fatalities from this.
It is tragic, and it is so preventable. Carbon monoxide, or CO, is a gas you cannot see or smell. When you breathe it in, it binds the hemoglobin in your blood more aggressively than oxygen does.
Wow.
It essentially suffocates your cells from the inside out.
And this happens because people are trying to stay warm.
Exactly. People bring charcoal grills inside. These camp stoves in the living room, they run generators in the garage. The rule is absolute. Never burn anything combustible indoors without proper ventilation designed for it. No grills, no generators, no using a gas oven for heating.
What about space heaters? I feel like every garage in Florida is being rated for a dusty space heater right now.
Space heaters are great, but they are a fire hazard. First, check the cord. Is it frayed? Second, the 3-foot rule. Keep the heater at least 3 feet away from anything that can burn: curtains, bedding, furniture, and place it on a hard, level surface. Do not put it on a rug where it might tip over.
And turn it off when you sleep.
Absolutely. Never leave a space heater running while you are sleeping. If a fire starts, you won't smell the smoke until it's too late.
Community is also a big part of the people category.
It is. Check on your elderly neighbors. As we age, our bodies become less efficient at regulating temperature, and we lose that subcutaneous fat layer that insulates us. A house at 60 degrees might feel fine to you, but it could be dangerous for them.
And the homeless population. This weather is lethal if you are exposed.
Oh, it is. Warming shelters are opening across the state: Central, Florida, Tampa, everywhere. If you see someone in need, please share verified shelter information. You can call 211 in most areas to get a list of resources.
Donate blankets, coats.
Donate blankets, donate coats. This is the time to look out for each other.
Okay, second P, pets.
This one is simple. If you're cold, they're cold. Bring them inside. Florida pets do not have winter coats. I don't care if it's an outside dog. Tonight, it's an inside dog.
What about larger animals?
For livestock horses, cattle ensure they have a windbreak and check their water. Water troughs can freeze over, and dehydration is a major risk in winter, too.
Third, P pipes. This is the one that causes the most homeowner anxiety.
It does, and for good reason. Water expands when it freezes. That is a unique property of water. But the burst pipe usually doesn't happen right where the ice is.
Really? Explain that.
The ice forms a blockage. Then, the water pressure between that ice blockage and your closed faucet builds up immensely. We're talking thousands of PSI. That pressure is what bursts the pipe.
So how do we stop it?
First, insulation. Wrap any exposed pipes, pool pumps, sprinkler heads, the main line coming into the house. Pool noodles, foam covers, or even old towels wrapped with duct tape work. You just need a barrier against the cold air.
And hoses. I see people leave their hoses connected all winter.
Disconnect them. If water freezes in the hose, it expands back into the spigot and can crack the pipe inside the wall. That's a huge, expensive repair.
Now the controversy. To drip or not to drip?
It is nuanced. The drip rule is generally for when temperatures are going to be sustained below freezing for a long time, usually near or below 20 degrees. This is mostly a concern for North Florida or the Panhandle.
So if I'm in Sarasota, I probably don't need to drip.
Probably not. But if you are in the hard freeze zone, letting a faucet drip lukewarm water helps in two ways. One, moving water takes longer to freeze, but mainly it keeps the valve open so that if ice does form, the pressure has a way to escape, preventing the burst.
And open the cabinets. I've heard that one.
Yes, open the cabinet doors under the kitchen and bathroom sinks. Let the warm air from your house circulate around the plumbing, and keep your thermostat steady. Don't drop the temp at night to save a few bucks. You want that heat in the walls.
Final pea plants. This is where we see the saddest sights the next morning. Black, mushy leaves.
It is. Florida's full of tropical plants that just hate the cold. Hibiscus, crotons, bougainvillea, citrus trees.
What's the difference between frost damage and freeze damage for a plant? Is there one?
There is. Frost is ice crystals on the surface. It damages the leaves, causing that burn. A freeze is when the water inside the plant cells freezes.
Oh, that sounds worse.
It is. When that water freezes, it expands and ruptures the cell walls. It's like a million tiny water balloons popping inside the plant. That kills the plant tissue.
So covering them is the defense. But you can't just throw a tarp on it, right?
No, material matters. Do not use plastic. Plastic conducts cold. If plastic touches the leaves, it will freeze them just as fast as the air. Use cloth sheets, blankets, burlap. Cloth traps air and insulates.
And the technique, how you put it on, matters.
You have to go all the way to the ground. You aren't wrapping the tree like a lollipop. You are building a tent. You want to trap the heat that is radiating up from the soil. Use rocks or bricks to pin the edges of the sheet to the ground. You are creating a little microclimate inside that tent.
What about potted plants?
Bring them in if you can. If not, group them together against the wall of your house. They share warmth and the house radiates heat. It also protects them from the wind, which dries them out.
And here's the big mistake I see people make. The day after the freeze, they go out with the pruning shears.
Put the shears down. Do not prune immediately. That dead brown foliage looks ugly, but it is nature's insulation. It protects the living parts of the plant deeper down from the next cold night.
So you wait.
You wait until the spring flush of growth, usually March, before you cut anything back.
That is crucial advice. Patience. Before we wrap up, let's touch on cars quickly.
Two things, batteries and tires. Batteries operate on chemical reactions. Cold slows those reactions down. If your battery is old, it might not have enough juice to turn the engine over.
And the tires, that little light on the dashboard.
Physics again, the ideal gas law. As the temperature drops, the volume of the air inside your tires contracts. You will likely see the low tire pressure light. Don't panic, you probably don't have a flat. Just check it and top it off.
That is a comprehensive rundown. We've covered the why, the deepening low and the atmospheric pump. We've covered the snow chances and the wet bulb physics. And we've covered the how, the 4 Ps of survival.
It really is about preparation, not panic. This is a historic event, a 1 in 15-year cold snap. But if you take these steps, you can mitigate the damage.
And maybe, just maybe, if you're in Pasco County on Saturday night, you might see a flake or two.
Just don't try to catch them on your tongue. They might be gone before you get there.
Fair enough. Well, that brings us to the end of this deep dive. If you found this breakdown helpful, please do us a favor. Subscribe, rate the podcast, and leave a comment. It really helps more people find the show. You can also follow the conversation on social media. Follow Meteorologist on Instagram, TV Meteorologist on TikTok, and check out Rob Jones Hurricane on YouTube. We have a specific Meteorology Matters playlist there where you can find all our deep dives. You've been listening to Meteorology Matters, created by meteorologist Rob Jones. Thanks for listening, and remember, meteorology always matters.